students. Today we will study the drift velocity from current electricity of physics class 12. So what is drift velocity? It is the average velocity gained by the free electrons of conductor in the opposite direction of externally applied electric field. As we know, for every conducting material there are many number of free electrons and they move in a random direction, like they don't have any defined direction, and in this course of random direction movement they produce their own velocity, but the net velocity of their randomness will be zero, and so we do not get any charge or electric current flow in a conductor until and unless we add or we just induce a voltage external electric field on that conducting material. So if I add here an external electric field, then we can see all these electrons tend to move in a certain direction, as this is the positive and this is the negative. The electric field occurs in this way. So the electrons then start moving in the defined direction from the opposite to the electric field, means electrons possess negative charges, so the electrons start moving towards the positive charge in a defined manner. So hence we can get the flow of current, which is called I or electric current. So now what is drift velocity? The average velocity gained by free electrons. As the electrons are free, so they don't have any other influence on it until and unless we can add an external electric field on the conductor. When we are adding this external field, they are getting an influence towards the positive end, and until and unless there is no electric field, there are some thermal velocities on the electrons for which they move in a random way and give some velocities, but the net of those velocities are zero. So here in this case, for the drift velocity part, as it is a velocity, we can use motion of one dimension here as well. So like we know there is a motion in one dimension, P equals to Q plus AT. Here we can use it like there are many electrons. If we take as a one electron as one particle, so V1, V2 and suppose then Vn, and we will take T as tau. What is tau? Tau is relaxation time. Now what is relaxation time? We know if one electron starts moving in a particular direction, when these electrons evacuate this space, we get a fixed positive ion here. Means if the electron moves from here to here, then this place will be replaced by a fixed positive ion. So this portion is a fixed part of this conducting material, and these fixed positive ions are acting as obstacles of this journey of the electrons. So when the next electron particle starts coming, it may collide on this fixed positive ion. So there is a continuous force of action like acceleration of electron, then it will collide with the fixed positive ion. They may collide with each other as well, but fixed positive ions are the most, they have happened to collide with themselves. Acceleration, collide, and this again start acceleration. So acceleration, collision, acceleration, in this course of cyclic action the electrons do perform while they do the journey from negative to positive side of the free electrons in the opposite direction of electric field, and hence we get the drift velocity in this manner, like their velocity increases and decreases, increases and decreases, so and so on. And the relaxation time is the time between, like this is a electron, this is a fixed positive ion, so and this is also a fixed positive ion, the electron is moving. So the time in between the electron moves from one fixed positive ion to one fixed positive ion distance means means the obstacle time, means the acceleration time or the moving time between two obstruction is considered as the relaxation time tau. So we take tau as a relaxation time. Relaxation time means that time in which electron moves without any obstruction. So we will take that tau in our motion of one dimension equation, and acceleration we will take the acceleration of the electron. So for every particle we can get a certain kind of equation. Like this way and so on and so on. So here we can see the acceleration we are taking constant, as the force acting on each electron is also constant. So the acceleration remains constant here in all equations. So if we do summation of the all particles, we will get like the drift velocity expression, which is summation of v1 plus v2 plus v3 and up to vn. These are all vector quantities, so we have to use those also. So the drift velocity we can, if we add all these expressions, we will get drift velocity is the average of all these summation velocities. So if we arrange those, we can get a such expression. Further arrange it, here we can see one thing, u1 plus u2 plus u3. These are the initial velocities of the electrons. So means you can say the thermal velocities of the electrons, and I said previously the net velocity or the total net velocity, thermal velocity becomes zero, as they have no influence of external electric field. So we can consider it at zero in further stage, and it only remains like this. And this is the average tau. This is the average tau, which is the average of all relaxation times. Now, so the VD becomes a tau. Okay. Now another equation we can get, like from the Newton's third law of motion, F equals to ma and A equals to F by m, and in the terms of electricity, F can be written as ue, and if we taking for electrons, then Q can be represented as the charge of electron. So A is the charge of electricity, and this A we got Vd equals to a tau. If we replace the A here, so Vd will become m tau. So this is the form of drift velocity portion. If we consider this as a vector quantity, so we will get the vector relationship of get the vector relationship of this form. So the electric field direction and the drift velocity direction both are in the opposite. Like I in starting definition mentioned, the average velocity is in the opposite direction of externally applied electric field. So we can use a negative sign here to denote the opposite nature of the vector quantity. So this is the all about drift velocity, and why we drift velocity need in our calculation, that we can study in the next lecture. Like why do we require drift velocity? We know the amount of charge flow has an impact on the flow of current or current electricity. So what is the relationship? Relationship is the I equals to NEFBD, where I is the flow of current, N number of electrons, E is the charge of electron, E is the cross sectional area that is using for the current propagation, and Vd is the drift velocity expression what we are achieving here. So if we get the drift velocity, we can calculate the value of I using the other physical parameters knowing. Thank you.